In this video, we're going to learn how to find confidence intervals for the population mean. Okay, again, an interval is a range of values where we suspect that the population mean could be inside this interval at some confidence level. The common confidence levels, guys, are 90, 95%, and 99%. So this question 3. So this is a continuation of the previous video that touched on the confidence interval for the population proportion. Now the remaining questions cover confidence interval for the population mean. Construct a 95% confidence interval for the population mean. Assume that the population is bell-shaped, has a normal distribution, a sample of 20 part-time workers. Okay, 20 is labeled as N, which is the sample size. Has a mean annual earnings of 13,120. This is X bar, guys, the sample mean. With a standard deviation of 2,677. This is S. He's referring to a sample standard deviation, so we call it S. Round to the nearest dollar. In order to find a confidence interval for the mean, we need 4 arguments. We need the confidence level, which is given right here. We need the sample standard deviation, which is given. We need the sample size, and we need the sample mean. And I'm going to show you how to use Statcrunch to construct the interval. Okay, here's what you do it. You go to Stat. You go to T-stat. If he gives you the sample standard deviation and he doesn't mention anything about population standard deviation, you have to go to T-stat. One sample with summary and then sample mean. Let's see, what was the sample mean? So the sample mean was 13,120. The sample standard deviation was 2,677. The sample size was 20 and the confidence level was 95%. And you can hit compute. And let me bring this to the center of the screen. And this is the interval, guys, is right here. Now you're wondering what's DF19. DF is degrees of freedom, which is a sample size minus 1. My sample size is 20. If you minus 1 from 20, you'll get 19. And this is the interval. He says round to the nearest dollar. So it's going to be 11,867 and 14,373. So let me write it down. So the confidence interval is the following. The mean is between $11,867 and $14,373. How do you interpret the answer in words? You say, with 95% confidence, we can say that the true mean annual earnings is between the true mean annual earnings for part-time workers, if you like, is between 11,867 and $14,373. This is how you find a confidence interval for the population mean by going to Stat, T-stat. And why T? Because he gave me the sample standard deviation. Anytime he gives me the sample standard deviation S, I use a T distribution. Where you can find, if you go to my course shell, you can find more information about the T, learn more about the T distribution and my notes under this chapter. Okay. Next question. The grade point average of 13 randomly selected junior college students are listed below. Assume that the grade point averages are normally distributed. Find a 98% confidence interval for the true mean GPA, round to the nearest 100th. Before I do anything, guys, here, I have to key in the data into Statcrunch. So let me just do that first. Okay, I keyed in the data. I put it under variable 4. It doesn't matter where you put it. So how do you find a 98% confidence interval for the population mean? Here's what you do. You go to stat, T-stat again, one sample. Now, no, not with summary, with data. And I select the variable, and I just select the confidence level right here. He wants 0.98. Compute. This is the interval, guys. So the lower limit is 1.93 and the upper limit is 3.42. So I go to my document. The mean is between 1.93 and 3.42. Interpretation. Let's type in the interpretation. With 98% confidence, we can say that the true mean GPA of junior college students is between 1.93 and 3.42. If I ask you a question, what can you say about the performance of class on average? I tell you, I don't know, because anything below 2.0 means a D, and from 2 to 3 is a C, above 3 is a B. So it could be a D, it could be a C, it could be a B. This is a very wide interval. And if you wonder why this interval is so wide, because the confidence level is so high. When your confidence level is high, which is 98%, the interval will become wider. And the other thing, guys, is the sample size is small. When the sample size is small, you get wide confidence interval. That means the lower limit and the upper limit are too far apart. So we learned how to use the t-stats in question 3 and in question 4. Let me show you question 5, which is a unique case here. A sample of 32 randomly English majors has a mean test score of 81.5. Now look what he says here. Assume that the population standard deviation is known to be 10.2. Once he gives you the population standard deviation, you cannot use the t distribution. You must use the z distribution, which is z stats. Round to the nearest hundredth, construct a 90% confidence interval. That should be a 90 here. 90% confidence interval for the population mean test scores. Okay, we need 4 arguments. We need the sample mean, which he gave it to us, 81.5. We need the sample size, which is 32. We need the standard deviation, whether it is a sample standard deviation, population standard deviation, it's 10.2. And we need the confidence level which is 90%. Let me show you how to do this. Okay, so we're gonna go to Statcrunch. We're gonna go to Stat. And this time, because he gives you population standard deviation, you need to go to Z-stats, one sample with summary. Sample mean, what is it? It's 81.5. Standard deviation is 10.2, if I'm not mistaken. The sample size is 32. And the confidence level, guys, is 90%. Compute right here. And here's the lower limit, 78.5. And the upper limit is 84.5. So 78.5 to 84.5. Let's write it down. How do you interpret this answer? With 90% confidence, we can say that the true mean test score of all English majors is between 78.5 and 84.5. Okay, last question we're going to do, which is again about the sample size. Finding the sample size when finding confidence interval for the population mean. An insurance company is trying to estimate the average number of sick days that full-time food service workers use per day. A pilot study found that the population standard deviation to be 3.5 days. So sigma, guys, is 3.5 days. This is not S, it's sigma. How large must a sample be selected if the company wants to be 95% confident, that's the confidence level, of getting an interval that contains the true mean within a maximum error of 1 day? Okay, this is the formula. I will provide the formula if I ask you to find the sample size. In order to find, just the sample size, we need sigma, which he gave me, 3.5 days, right here, guys. And then we need E, the margin of error, which he gave me, which is 1 day. And then we still need to find ZC, but he gave me the confidence level, and I showed you earlier how to find ZC if we know the confidence level, and I want to show it to you again. You just go to Stat, Calculators, Normal, select Between, put the confidence level right here, 0.95 in our case, and hit compute, and look, you get the 1.96 again. So we can go to the document, and I'll show you what I put there. I put n equals 1.96. This is ZC. Sigma is 3.5 divided by 1, then square it. And let me give you what the answer is. Okay, so the answer is 47.0596, but sample size can't be a decimal. So what's the minimum sample size required? Is you need to round this up to the next whole number, which is 48. And that concludes everything, pretty much everything that you need to know in this chapter. I would like you mainly to focus on how to find the intervals. So mainly question 4, question 5. Question 5, it's not a common case that we know the population standard deviation. Most of the time we don't. So I would focus on question 3 and question 4 and finding the confidence interval for the population mean.